Today we are going to discuss about a carbon and its compounds. In this, what is a carbon? Carbon, we know that it is an element which is having atomic number 6 and atomic mass as 12. Number of number of electrons is 6, number of protons also 6, number of neutrons also 6 in this carbon. Why carbon and its compounds? Because a carbon is having even though isotopes also. When we are discussing about isotopes, I have given this example also. C612, C614, C613, C614. These are the isotopes of a carbon. And carbon is exist in natural form. Natural form means singular form, means individual state, and also combined state. Combined state means like as carbon is exist as a carbon. Carbon is can exist as a carbon and also in combined state. For example, CO2 and CaCO3, carbon is there, and organic compounds. All these are combined formation of carbon. Organic compounds. Now, it is exist in individual form. Individual form as a carbon it can exist. That is called as another form, allotropes. Allotropes. Allotropes means it is having the same carbon only. It is same formula, same substance, but existing in different forms. Existing in different forms is called as allotrope. Allotrope means the substance which is having same formula but existing in different forms is called as isotopes. Carbon is having the isotopes. Number 1, diamond and graphite and Buckminster fullerene. And graphene also there. Graphene also there. These are the 4 allotropic forms of carbon. In this diamond, we know that diamond is very strong in its nature due to its case-like structure. Diamond is having the case-like structure, means only carbons are there. Carbons in this diamond, carbon is having sp3 hybridization. We already discussed about hybridization in chemical bonding lesson. So it is sp3. So it is sp3 hybridization. Sp3 hybridization means what is the structure? Tetrahedral structure. Tetrahedral structure. So each carbon is having tetrahedral shape with another carbon. Again, this is having tetrahedral shape. So the overall structure is becoming as a case-like structure. Becoming as a case-like structure. So it is a very hard in nature. Diamond is very hard in nature due to its structure. And it does not conducts electricity. There is no free of electrons. Conducts electricity. Does not conducts electricity. Who? Diamond does not conducts electricity. Does not conduct. What is the reason? There is no free of electrons. No free of electrons in diamond. That is about diamond. Diamond also one of the allotrope of carbon. It is having sp3 hybridization, and it is, due to the sp3 hybridization, It is in tetrahedral shape. Due to the tetrahedral shape, all carbons are arranged in tetrahedrally with a case-like structure. Due to its structure, it is very hard in nature. There is no free of electrons, so it does not conduct the electricity. And again, another one, graphite. If we take a graphite is a sp2 hybridized carbon. sp2 hybridized, all carbons are arranged hexagonally, means like this. All these are carbons only. Hexagonally, and this again, because a tetrahedral structure should be there for sp2 hybridization, so like as hexagonally they are arranged with each other in two layers. Structure will be there, here one layer, and due to the sp2 hybridization means we know that this is carbon's outermost configuration, excited outermost configuration. One s orbital, two p orbital are combined together, sp2 hybridization. Here one free electron is there. Due to the free electron, it conducts electricity. Graphite conducts electricity due to the presence of free electron. And due to the free layer structure, it is not hard like as a diamond. It is soft in nature. And we are using as a lubricant and as a pencil lid. We are using as a pencil lid. So these are the useful and structure of a graphite. When we are going to the Buckminster fullerene, it is not in nature. It is created in lab. It is not in nature, it is created in laboratory. In these 60 carbons are there. Those 60 carbons are arranged in hexagonal structure, like as a what is that, a football like a structure. Football like structure this is. And come to the graphene. Graphene is extracted from graphite. It is also having hexagonal structure and very hard in nature, harder than steel. So these are about allotropes of carbon. 4 types of allotropes. One is a diamond. Graphite is very important. In these they may ask the question, in diamond where we are using to cut the hard objects, and in jewels. So diamond and graphite. In diamond sp3 hybridization, graphite sp2 hybridization. Diamond does not conduct electricity, but graphite conducts electricity. It is hard in nature, it is soft in nature. That is the difference. These two are available in our nature, no problem. But Buckminster fullerene is not available in nature, but it is created in laboratory. It is having football structure. 60 carbons are arranged with cyclohexane structure. And graphene is extracted from graphite. It is also having hexagonal structure, hexagonal, no problem, hexagonal structure, and it is very harder than steel. That is about isotopes of carbon. Carbon In organic chemistry, all organic chemistry is a branch of chemistry. Organic chemistry is one of the branch of chemistry. We have inorganic, organic, physical. Three types of chemistries are there. Organic, one of the branch of chemistry. This organic chemistry is depends on carbon only. Means all organic compound contain carbon only. There is no compound without carbon. There is no compound without a carbon. So organic compounds means nothing but carbon compounds only. Why? That much the first organic compound is urea. NH2 C double bond O NH2. Urea is the first organic compound which is NH4CnO. Ammonium cyanoate. On heating we will get urea. This is the first organic compound which we prepared in our laboratory. Right. Why carbon is having that much important in organic chemistry? Why not any oxygen or halogen, any another compound? Why not? Because carbon is having the valency 4. Valency 4. Okay, what is meant by valency 4? It is able to form 4 bonds. Able to form 4 bonds. Okay, there is no another compound to form 4 bonds. Yes, it is there. More than 4 bonds also they can form. But why carbon only? Due to long chain formation. Long chain formation. Long chain formation. Long chain formation which is called as catenation. Catenation property. What is meant by catenation property? By linking with carbon, it is able to form a long chain. There is no another elements is having this property. Catenation property means formation of a long chain with the same element. See, carbon, long chain it is able to form. And after that, formation of multiple bonds. Multiple bonds. What is meant by multiple bond? It is able to form C bond C means a single bond between 2 carbons, double bond between 2 carbons, triple bond between 2 carbons in different molecules or in the same molecules also. This is available. There is no another element like carbon to form single bond, double bond, triple bond at a time in a single molecule or different molecule. So due to these 3 reasons, carbon is having more importance in organic chemistry. Now we are going to see about the multiple bonds of carbon briefly. Right. Organic compounds. If we take organic compounds are also called as hydrocarbons. Why hydrocarbons? Carbon is having more importance in organic chemistry. Why it is having that much importance, that we discussed. Even though hydrogen also not importance, carbon is bonding with hydrogen. So this is called as hydrocarbon. These hydrocarbons are 2 types. One is open chain hydrocarbons. Open chain hydrocarbons I am writing as HC. Open chain hydrocarbons. This is called as aliphatic compounds. Aliphatic compounds and closed hydrocarbons. Ring form of hydrocarbons. Right. In these aliphatic hydrocarbons, again 2 types. One is saturated hydrocarbons. Another one is unsaturated. Saturated hydrocarbons means a carbon is able to form 4 bonds, right? If these 4 bonds are satisfying with the hydrogen, all are sigma bonds, single bonds. You know very well about a sigma bond and a pi bond formation in chemical bonding we discussed. All are sigma bonds. All are sigma bonds. Carbon is satisfy the 4 valency with the sigma bonds, that is called as saturated compound. Means carbon satisfies its tetravalency. 4 valency we are calling as what? A tetravalency with sigma bonds. With sigma bonds. You may think that 4 valency is satisfying means this is also 4 valency is satisfying. No, 4 bonds is forming. But this is not. One is sigma, one is pi. One is sigma, one is pi. Not like that. All are should be sigma bond. That is called as saturated compounds. Saturated compounds. These saturated compounds are called as alkene. Is it visible? Sorry, alkane. Is it visible? That is called as saturated compounds are called as hydrocarbons are called as alkanes. Alkanes is having the general formula CnH2n plus 2. Right. This is full information about saturated hydrocarbons. What is the name that we will discuss? Saturated hydrocarbons, again 2 types. Unsaturated means you may think this, you can guess it. Saturated means carbon is satisfying tetravalency with sigma bonds. Means what is going to be? Unsaturated means carbon has to satisfy. In any compound you can take, a carbon has to satisfy with 4 valency. So 4 bonds are compulsory. 4 bonds are compulsory. They may be not only sigma bond. If all are sigma bond means that is saturated. Means unsaturated means all are not sigma bond. So it should be pi bond. So pi bond means we have double bond also there, triple bond also there. Double bonded compounds we are calling with alkene. Alkene. Alkene means unsaturated means which has multiple bonds. The compound which has multiple bonds. Multiple bond means you may think that again one more doubt. Which is double bond or triple bond? No problem. Double bond we are separating both. Double bond means we are calling as alkene. Triple bond means we are calling as alkyne. So double bond. Double bonded compound. Double bonded compound. Alkyne, alkyne, YNE. These suffix is very important. End of the name is very important. YNE, ENE, ANE. Alkyne. Triple bonded compound. Triple bonded compound. Triple bonded compound. Right. Double bonded compound. General formula is CnH2n. Triple bonded compound is CnH2n minus 2. If you observe, the number of hydrogens are increasing. The number of hydrogens are increasing from alkane to alkyne. Means the number of bonds are decreasing. Means due to the formation of pi bond. That is the difference. Here only sigma bonds insaturated. Here pi bonds also there. Pi bonds are present in double bond and triple bond. If double bond is there means that compounds are called as alkene. If triple bond is there means that compounds are called as alkyne. Now we are going for closed hydrocarbons. I hope you understand this. So we discussed about, now we completed full-fledged about aliphatic hydrocarbons, alkanes, alkenes, alkynes and their general formula. And coming to the closed hydrocarbons, closed structure of hydrocarbon. This closed structure means like this. Open chain means aliphatic means like this. CH3, CH2, CH2. Open chain, this one. Closed chain means like this. CH2, 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 CH2 bond. See, 3. This is closed. Wherever you are starting, going to there on. That is closed structure. Now, if you take these closed are 2 types again. That is homocyclic. Always we are going with the homo and hetero. This is heterocyclic. What is a homocyclic? Homocyclic means, for example, if you take, this is a ring structure. I hope you understand. This is ring. This is also ring. This is also ring. What is the difference between this ring and that ring? Here, the ring is containing only carbons. The ring is formed by the closing of the carbons, but the ring is formed with one more, another atom is there. This atom is called as heteroatom. So, if the cyclic structure with only carbons, that is homocyclic. If any heteroatom means oxygen, nitrogen, phosphorus, sulfur, this type of compounds, this type of elements in cyclic structure, that is called as heterocyclic. You may think that, for example, I added OH here. This is also homocyclic. Only in cyclic frame only we need to check. Other than that, we don't want. Right, homocyclic and heterocyclic. In homocyclic, again, aromatic, non-aromatic. What is meant by aromatic? Aromatic means it should have, if we discuss about aromatic, you can understand non-aromatic. Double bonds, alternative double bonds. Alternative double bonds should be there, number 1. Number 2, 4n plus 2 pi electrons should be there. For example, we can write the example like this. If you observe, carbon. This is, or otherwise, to understand. If I write like this without writing the carbon, what is the meaning? Every corner is having the carbons. At corner, carbon atoms are there, right? In this alternative position, I am writing the double bonds. Right? Is there no? In this position, double bond. There is no double bond. Alternative position. How many pi electrons are there? I already told you, double bond means bond is nothing but covalent bond. Organic compound contains covalent bond only. So, bond means 2 electrons. So, for each bond 2 electrons, 2 pi bonds are there. 2 pi bonds is equals to 4 pi electrons. Is it satisfied in this formula? If you take n is equals to 1, 6 electrons should be there. If you take n equal to 0, 2 electrons should be there. But 4 pi electron, it is not aromatic, non-aromatic compound. For example, I am taking this one. This is alternative. How many carbons are there? Count it. Come on. 1, 2, 3, 4, 5, 6. Right. 6 carbons are there. Now, at alternative position it is there. So, first rule, okay. Second rule, come to. How many pi bonds are there? 3 pi bonds are there. 3 pi bonds, right. 3 pi bonds. 3 pi bonds means how many electrons? Right, 6 pi electrons. Is it satisfied if you take n equal to 1? N means number of rings. Here how many rings are there? One ring. So 6 pi electrons. So it is aromatic. Aromatic. So the first example for aromatic compound is this one. What is the name of this one? Benzene. Very important, very important, very, very important, benzene. How many structures are there for benzene? Seema, this is one structure I already given. And you may think that yes, that is only. Why not alternative position only? You can draw like this also. Like that also you can draw, no problem. Benzene ring. Or we are unable to draw at alternative position, you can make a ring in middle. This ring represents the 3 pi bonds at alternative position. These 3 structures are called as a benzene. Actually, the formula of benzene is C6H6, that carbon 6, hydrogen 6, we arranged like this. The structure of benzene ring is C6H6 and these 3 are structural formation of benzene ring, that is aromatic and non-aromatic. This is about closed hydrocarbons. Now we are going to discuss about alkanes, alkenes, alkynes. Before going to that, we need to discuss about root word. Means if when we are giving the name to the organic compounds, what is the name when one carbon is there? We need to call as meth. 2 carbons, eth. 3 carbons are there, prop. 4 carbons are there, bute. 5 carbons are there, pent. 6 carbons, hex. 7 hept. 8 oct. 9 non. 10 dec. With these names, we need to call the compound if they are having this many number of carbons. How we can call that? So I hope you are copied. And come to the alkane. What is the alkane general formula? We already discussed. Alkane general formula is CnH2n plus 2, right? Alkene general formula CnH2n, that also you know. Alkyne general formula CnH2n minus 2, right? This one. Now N means a number of carbons. N means a number of carbons, right? If we are changing the number of carbons, formula, one formula we are going to get, right? And what is the name? Name we need to write alk plus ane. Alk plus ane. With this name we are going to get. Alk means root word. Means based on number of carbons, right? Now, for example, if n is equals to 1, what would be the formula? C1 H2 plus 2 H4 means CH4. That is the formula we are going to get. C1H4. What is the name of this one? One carbon is there means meth. The root word is meth plus ane, methane. Methane. For example, n is equals to 3. I am not writing up to 10, but I am writing only minimum. How can you understand? C3. H2 3s are 6 plus 2, H8. C3H8. You can substitute in that formula. 3 carbons are there means what did you call? Prop. Prop plus ane, propane. 2 carbons are there means what did you call? Eth plus ane, ethane. For example, C6 are there. N is equals to 6. C6. 6 2s are 12 plus 2, 14. H14. 6 carbons are there means what did you call? Hex. Hex plus ane, hexane. This ane is very important. Hexane is very important. I hope you understand. Now coming to the, not this one, we will discuss that later. Otherwise we will discuss here itself, no problem. Come to the n is equal and n value and formula and name for alkene. For alkene, we are going to discuss about alkene. N is equals to number of carbons, same number of carbons. N is equals to 1. N is equals to 1 means C1H2. CH2. Here, if you observe, CH2 is we are calling as alk plus ene. Alk plus ene. Meth plus ene, methene actually. Methene. But if you observe, CH2, carbon always should has its tetravalency. Four bonds should be there. You may think that with two carbons, two hydrogens, two bonds. Hydrogen is able to form only one bond, I already told you. So only two bonds are there, remaining two bonds are not there, so it does not exist. Does not exist. So alkene is does not start with N equal to 1. One carbon alkene is not there. Now coming to the N is equals to 2. N is equal to 2 means what would be the formula? C1H4. Correct, no? So, no. C2H4. C2H4. C2H4, what would be the name? Eth plus ene, ethene. Eth plus ene, ethene is the formula. For example, N is equals to 5. C5, 5 2s are 10, H10. Pent plus ene, pentene is the name. Pentene. Okay, and alkyne. Come to the alkyne, N value, N is equals to number of carbons and formula and name. Is it visible? Is it visible? Equals to number equals to number of electrons, the formula, name. N is equals to 1 as usual. C1, H2 minus 2, 0, right? So it does not exist. Does not exist. Only carbon without any bond, carbon does not exist. N is equals to 2. C2, 2 2s are 4 minus 2, H2. What is the name? Alk plus ine. Alk plus ine means 2 carbons means eth plus ine, ethyne. Ethyne. Like that we need to write the name. For example, N is equals to 8. N is equals to 8. C8, 2 8s are 16 minus 2, 14, H14. What would be the name? Oct. 8 carbons means oct. Oct plus ine, octine. Oct plus ine, octine. This is the way to write the name. I hope you understand. I hope you